Welcome everybody to this session during IIoT World Energy Day. Thank you for joining us. We've a couple of thousand people registered and coming in from over 80 countries. So thank you for joining this session. Using digital twins to enable AI control of building energy management. And I'm delighted to be joined here for this session by John Burton, the CEO and co-founder of Ursula Leo, and Nicholas Warren, the CEO and founder of Winio. Now, before we dive into the topic, just a couple of bits of housekeeping. The session will run for about 55 minutes. It's primarily a panel discussion amongst John, Nicholas, and myself. But obviously, all of you watching live, feel free to ask any question to us using the Q&A button in the bottom of the screen. That's how we keep track of all the questions coming in. Feel free to use the chat. Let us know where you're joining in from today. And you can chat amongst yourselves. But if you have a question, the only thing we'll be watching for is in the Q&A. Now, at the end of the session and at the end of the day, the IIoT World team will be making a draw for folks who have asked questions. There'll be some copies of the keynote speech this morning, the book from the author, and also there'll be some yearly memberships to the IIoT World community. So we'll keep it as engaging as we go. The format is, as I say, kind of a panel discussion. Please do throw in any questions as we go along, and we'll try and deal with as many of them as we can. For those of you who are familiar with IIoT World, you'll know that IIoT World is one of the leading industrial Internet of Things online community and platforms out there, running many events like what we have today with the IIoT World Energy Day and many other different days. And obviously, if you follow online, you'll see daily updates, lots of information. We'd like to thank all of the sponsors that make this day possible. And obviously, our sponsor here, Ursula Leo, for this particular session. So with that, let me ask our panelists to do a quick introduction. John, how are you doing? And for folks that don't know you.
Hey, thanks. Thanks, Kevin. So yeah, John Burton. I am, as you said, the CEO and co-founder of Ursula Leo. We're based out of San Francisco. We've been doing digital twins for 3 or 4 years now, using Unity Gaming Engine as the main graphical rendering platform. So buildings has been one of our main markets, probably our major focus at the moment. Building energy management is the leading interest that everyone has. So we're pretty active in that space. And we, got to know Nicholas over the last 6-9 months, and been working with him on some projects in Sweden. So that's kind of where we come into the picture. We're doing the digital twin piece of this.
Thanks, John. And Nicholas, as John said, I believe you're up in Sweden.
Yes, I am. I don't know if you can see it behind me, but I'm definitely in Sweden. Originally from Colombia, though. So the one in the chat that was from Colombia. Hello, nice to meet you, and everyone else. So I'm the CEO and founder of Winio consulting company that has been specializing on digital twins the last, I would say, 3 to 4 years. Before that, working with, I wouldn't say smart buildings, but trying to make them smart at least. So dumb buildings, and then working with companies like John and Ursula Leo in sort of to getting them smart. The background is strategy, innovation, and entrepreneurship. Works with, again, like global digital twinning for national digital twins, global twinning, and in energy, manufacturing, and a lot of different places. So working with AI-related, questions the last, I would say, 3 to 4 years as well, to be honest. So it's really, really good to be here. And I'm really looking forward to an engaging, discussion with John and getting fielding questions from the audience.
Okay, thank you, Nicholas. Thanks, John. So the focus of the topic for the next, 50 minutes or so is using digital twins to enable AI control of building management, building energy management. Now, let's break that down a small bit. So if I may, John, when we talk about AI control of building energy management, what do we mean by this?
Yeah, so building management systems obviously have been around for a while. But it's a lot of complex interacting systems inside of a complex building, a large building. So we've got heating systems, cooling systems, chiller systems, snow melting systems, cooling towers. There's a large amount of complex things that interact with each other. So the traditional way of doing it is obviously you have a facilities management team, and they are experienced. They kind of understand how to run the building. They understand how to get the best out of it. But that requires quite a bit of human control. I mean, you can automate lots of it, but to really get the best, you're going to have, depending on the weather outside, you're going to be controlling the building slightly different if it's warm, cold, whatever. So it seems like an obvious place to bring in artificial intelligence, which, on paper can learn the best way to operate the building, and then do it optimally and do it at a much more granular level than you can do it with a human operator. So that's kind of the goal of what's going on in this space. People have been picking at the problem for a while. You see people doing it with just HVACs, but we're trying to look at a whole building, multiple complex systems, and how do you actually get an AI trained and able to run a building efficiently.
And Nicholas, if I ask you the same in terms of where do you come from with AI control?
Definitely. I mean, I love the question, and thanks, John, fantastic answer. And I think if you go back to building energy management or building automation systems or BMSs and energy systems, I mean, digital twins, if you also, go back a little bit, what is a digital twin? Digital representation fed with real-time data at certain intervals. Building management systems and everything, being controlled in buildings has not historically been real-time, right? And energy predictions has been, pretty passive. And you set up something, this is what we think will happen. And you have like PID loops that control the energy systems, and everything is get reported, also, a couple of months afterwards. It's not granular. It's definitely not real time. And again, like to John's, what he was saying, it's definitely not always like, catering or taking in information from other systems. It's again, like, it's something that was made in the past to make a prediction of something that will happen in the future. And then we spend an eternity of, getting that to work with facilities managers or technical asset managers. And, it's not real time. And the propensity or the, getting access to it with AI is a challenge, has been a challenge, and will be a challenge as well. So I think, the digital twin sort of comes first in, making this, much easier to utilize AI than anything else. But yeah, in comparison to what has been done and what has been doing in terms of energy management, I think is, definitely revolutionary. It is not necessarily easy to get there, which I think, what we're going to talk about today, how to get there, what are the benefits, and a little bit about that.
No, exactly. And in terms of, as you mentioned, like, how do you get there? Because we've all been hearing the buzzwords for many years. Oh, we use AI to do this and whatever. But John, if I may come back to you around AI just doesn't turn up on a piece of software and you install it and it runs. You mentioned you need to train it. So for people that may not be familiar with AI and some of the concepts, what do you mean by training an AI?
Yeah, so AI is just a mathematical technique or a statistical technique for a computer to make decisions based on previous data. So the first thing you've got to do is supply it with a large amount of data, and that's how computers learn to talk in the modern world. That's why Google and Siri can actually understand your speech, is because they've been trained on billions of hours of people talking, and they've been over time they get better and better at it because they get more access to more and more data. So the first thing we've got to do if we want to use AI for a building is put data into the machine learning algorithm that shows how the building should work, and give it a feedback loop that it can optimally optimize the building for the best operation. So that's really where digital twins come in, is getting, this is the biggest challenge in AI, is getting clean data to give to the computer so the computer learns what to do.
Now, in the world I grew up in, back in HP, Compaq, Intel, over the last 2 decades, we always had the concept of, well, if you give a computer bad data, you'll probably get a bad result. So I suppose when we say we feed data to the AI system learns, how do we make sure the data it gets is good?
Yeah, it's a good question, and I think, like, it's not even with working with AI, it's like bad data and disaster out. So it's not even equals, it's even worse, right? So in terms of building automation or building energy systems, you want data from the actual building. In the US, we have building automation systems or standards like BACnet, which is the world's largest, building automation standard. Makes it easier to get data out from the building. But that doesn't mean that you know exactly where it's coming from. So that's, you know, there's always this cleaning process in understanding where is the data coming from, what does it look like, and then you have taxonomies and ontologies, basically frameworks that will tell you, you know, how to tag this data. Because, you know, otherwise the AI or machine learning algorithms, they are going to get data, you know, both from one silo, but also from a lot of different silos. And it's important to understand how this data comes together, because one thing from one vendor, which is the same from some other vendor, but they name it differently. And these kind of, you know, things creates havoc for, you know, when you want to train the engine, because they don't really know what they're talking about. So I think like there are a lot of, you know, fundamental things that needs to happen before you get to that stage. So there's, I think like, you know, digital twins are very useful when it comes to bringing interoperability between systems. But something that John didn't say, which I also think is probably even as important and almost more important, is the visual aspects that John, you know, what they excel at Versaleo, to bring in understanding as in, where are we? You know, what are we talking about? Because if you show a Jupyter notebook from a data scientist to a technical asset manager, or to me, or to an energy specialist, or to a decision maker, you know, they're not going to understand what we're saying, right? So having the digital twin act as a representation or visualization of, you know, the different algorithms, and basically what you said, Kevin, you know, how do we know that this is good? Well, if we train something and then visualize it with, you know, our Versaleo or digital twin, you know, platform, we can actually see that, you know, this is not optimal. This is not how it should behave. So creating that feedback loop between AI and, you know, digital twinning is really, really important, not only for systems to provide interoperability, but definitely for people to understand, you know, across different domains, you know, does this look good? And then basically have an interface to show that to people, because you can't do that with Jupyter notebooks, energy management software, building automation stuff that only caters to one domain. And the problem with, you know, when we're working with smart buildings is that it caters to all different domains. So I think like that you need to use it not only for systems, but also for people as well. But John, you're free to disagree. Maybe you've seen something.
Oh no, I think you do this stuff deeper than I do, so I'm learning.
Now we come back to digital twins because I'm a big fan. But I suppose one of the things for the folks out there, I happened to be up at Hanover Messe last week in Hanover, obviously, and everybody had a digital twin.
Yeah.
But if I asked 11 people or 10 people, what's a digital twin? I probably got 11 answers.
Yeah.
So from your perspective, and I suppose, John, if I may go to you first, when you say digital twin, what is this? Is it a process, a physical model? Is it a 3D model? What is it?
Yeah, unfortunately, it's a term that got very popular, I don't know, about 3 years ago, 2 or 3 years ago, and everybody jumped on the bandwagon a little bit. So, yeah, you get people who've just got a database of numbers, and they say, oh, it's a digital twin of a building because the numbers represent what's going on in the building or the piece of equipment. From our perspective, it's all about data visualization. So the digital twin is a way of showing a 3D model of the building. And as I say, we use Unity Gaming Engine just because it's very graphical and runs on anything. And then we enhance that data. So we bring in sensor readings or other data points into the 3D model. So you're looking at the whole building in one screen with all the data that's being collected. And then to Nicholas's point, we then need to enhance that data in ways to make it useful. You're talking about, you know, I was talking to a company last week in Pittsburgh. They're collecting over 6,000 data points from a building across 10 different systems. So how do you visualize that data in a meaningful way? You know, traditionally it's been done on 2D dashboards. Well, 6,000 data points is 500 dashboards or something. At least. So how do you, as you're tuning the building and changing, and they've got chiller systems and they've got heating systems and all these things mess, you know, as you change one thing, it changes other things. So how do you display that data in a meaningful way? You can't really look at individual sensor readings. You have to give much more of an overview and a visual overview of what's going on in the building. Of course, you allow people to dive down to individual sensor readings, but really the person who's trying to optimize that building needs to be able to see all that data in one place. That's what we call a digital twin. The whole building, one screen, 3D realistic model, enhanced with various gaming technology techniques. So it's and can be looked at in augmented reality or whatever. But it's a twin of the building that physically represents the building in a way you can actually see what's going on.
Yeah.
There are lots of other definitions of twins. They're all valid.
Yeah. No. But I think, I mean, you said something that is extremely important. That where you said if you change something somewhere, right, that will have an effect on something else in the building. Usually, people don't understand what that effect is, and see that hopefully before, so actually makes that within the digital twin, right? So you make that simulation first and say like, okay, what will happen if I do this? And then if you have like a model of the building fed with real-time data, you can actually simulate this so that you don't have to make mistakes in the real world, right? And I think like getting that instantaneous feedback so that you can again sit different domains, basically on a campfire, which is the building or the reality that you're looking at, in this case buildings, that makes it possible to not only see what's going on in the real world, but actually try out scenarios with the digital twin, and also asking the digital twin, right, what is the best course of action here? What do we need to do? Or train it to be a target point, as in we want to reduce 20% energy without forsaking people are gonna die because you're gonna suck out all the CO2 in the rooms, or it's gonna be too cold, whatever. So run these parametric models again with the simulation, asking the digital twin what is the best course of action right now, being fed with a response that you can understand, and then say, okay, let's implement this and actually run the building a couple of minutes or hours from the future. So I think the ability to get this instantaneous feedback, both from different systems as well as to people that people can understand, is something that is really, really hard, if not impossible to do when you have what John said, right? You have 10 different systems that cater to different departments with people that are monitoring them or just turning off alarms with energy systems. Getting that real-time perspective, making decisions about it, either from real time or even better in a simulated way, or even asking digital twins what to do, that's sort of a major differentiator between anything else that is going on in fragmented silo systems that can't speak with each other or can't convey information to anything else outside the domain. So it's a drastic change, definitely.
Now, the questions are starting to fly in here. So if I may, I'll start picking a couple up here. There's a question here, John, probably for yourself, from Cheryl. And she's making the point that from where she sees it, many industrial segments, the initial digital twin is kind of created off the 3D model when they built it. And the minute they built it and handed it over to whoever is using it, the fidelity of the model, the things don't update and things get lost and change and whatever. You mentioned you were taking, let's say, real-time data and feeding that into the twin. So how do you guys deal with that from here's what was built, but here's what it is today, and in a 3D model that it represents what it is today?
Yeah, there's a couple of different techniques to get the twin accurate and keep it accurate. So really the twin's derived either from CAD drawings for more modern buildings. So, the architect built, when he designed the building, they did it in 3D CAD. Or it's done from a scan. So somebody goes in and does a LiDAR scan of the building, and then goes through a process and gets turned into CAD and then gets turned into the actual digital twin. We do a lot of work with Unity. We're in the same town as Unity. They have a dedicated team to the whole industrial space. So there's a lot going on about how we can pick up changes automatically. There has to be one central piece of truth. So somebody somewhere has to say, okay, this Revit model, which is the most common architectural CAD, this Revit model is going to be what's really going on inside the building. And as I make changes, the architect or whoever's making changes to the building will make changes to that CAD. We can then pick up those changes from the CAD and automatically apply them to the digital twin. But it is definitely an area that's still developing. Manufacturing is probably the trickiest, because what happens in manufacturing is a lot of stuff gets moved around. The production line gets reconfigured, and obviously keeping that updated is another challenge. One of the reasons we do buildings and not typically manufacturing production lines is buildings are relatively static. Okay, they put up a wall, a new doorway, but it's not happening every day. But it can be done. There is a lot of work going on between us and Unity. And I'm sure other people in this space as well, to pick up changes. It is possible now to scan very regularly. Scanning prices have come down a lot. We have some partners in that space, and you can scan once a day, and then have that converted, and it'll be about maybe a couple of days to then get it into the Unity model. But yeah, it's definitely a challenge. Good question.
Yeah.
Sorry.
No. I mean, I've been working with general contractors and total contractors as well, and I mean, it's absolutely spot on. I mean, even if you get the BIM model or Revit file, it's not necessarily granular enough anyway, right? It has been maybe created as design. It hasn't been used to its full extent during the construction part, and then again, like it's dies an imminent death when it gets transitioned into the entire life cycle. So the life cycle focus doesn't necessarily exist. However, if you look at some of the implementations that digital twins are doing, you can also feed computer vision analytics with CCTV cameras instantaneously and having that recalculated in real time as well. So I mean, like, there are things going on. I think, like, also especially in the manufacturing space, that are driving these things, and also aerospace, and these kind of things that is slowly but surely getting into building automation, digital twinning, which can create this the life cycle digital twin that optimizes itself. If something changes, it could change itself. But that's also, again, what John was saying, that having open APIs and working with standards where you can get data from other systems, that is really, really important, because you might not necessarily need a visual something. It's just that okay, someone did a work order change and change something in the building, and feeding that into the digital twin as an alert. Okay, we need to update this, or just having this continuous feedback loop is really, really important. And there are a lot of different ways to get that done, definitely.
Mm-hmm.
And if I may, Nicholas, you just mentioned, let's say, CCTV cameras or whatever. John, you said scanning, and when you say scanning, is this, it's photogrammetry, CCTV, whatever, LiDAR, 360 photos?
A mixture of LiDAR and photogrammetry is the most common one we see. LiDAR gives you accurate dimensions, and photogrammetry gives you colors, textures. And you can derive, you can use photogrammetry now and actually derive physical dimensions, but LiDAR is typically more accurate.
Okay.
No, I definitely agree. And again, just a point as well, when you do scanning, again, the companies where you scan and they can have intelligence within them where they reverse engineer so that you can actually find the products, what are we looking at, identify different windows, wall sections, HVAC equipment, whatever that is, so you can automatically populate digital twins like Leos with information from that space, where you don't necessarily have to put a lot of manual ways of working to it. And again, like, there are a lot of open source stuff going out there related to computer vision standards that help out in creating faster time to value, because I think that's what it's all about. Saving money, making more money, possibly finding new revenue streams, and hopefully in a sustainable way, especially when we're talking about energy.
No, and there's a couple of questions coming in on the sustainability, and we'll come back to that in a few minutes. Sure. But again, just kind of to build it up for folks. So you create the digital twin, as you say, from the initial building designs. They're all 3D models. You make sure they represent the real world with real world scans and mapping that in. And you then mentioned that you integrate all of the real-time data coming from all the sensors into that. And then I'm guessing is that it's that real-time data and probably some human knowledge that you're then training the AI to go. John, you mentioned that, whatever, there's 6,000 data points. You can't be jumping into each individual one that triggered. You need to be able to go, well, if that triggers and that triggers and that, this is the problem. It's not the individual. What's the root core problem as opposed to the individual sensor, the temperature's too high or whatever. The training of these models, if I may, can you give people an idea? Is this something that you train one building, you can take that to another building and kind of modify it, or do you have to start from scratch everywhere, or how does that iterative process happen?
Yeah, that's a Nicholas question.
No, I think it's a great question, and I think, like, historically, creating or like doing AI or whatever machine learning, programs or projects has been, limited by both contextual factors that you look at very, very, in siloed ways. So once you want to add more data, you get stuck because you built a model that is very rigid, that is very, very specific, that is not easy to transfer into either other areas or to other buildings, to other domains. And it's also, historic, buildings are maybe going that way as well, cloud native or cloud native strategies. Whereas right now, there's also, the possibilities to have more distributed intelligence combined with cloud, so you have a hybrid approach. So in terms of, like practically what we've done in this project of working with Ursuleo in terms of AI and machine learning is that, again, like the most important thing has been to, work with people from different domains. You have the data scientists, you have me, you might even have the principal, you have the technical asset manager, you have the energy specialist, and even the smart heating people that needs to sort of like convey information between each other and say, like, what are we after? Well, how are we going to train this, right? How do we know what is the best way? How do we know when to succeed? And that initially comes a lot from people. And usually what, frustrates me a lot, when you're working with AI or machine learning, teams, a lot of times they have to do like a literature study, right? About the very domain that they have to work in. And I think that is insane because, how can you actually learn anything in 1 month, 2 months, and 3 months compared to some person that worked with this for 25 years? That is a specialist on that very building or that very asset. What we need to do is use digital twins and, convey that information for that person to say, okay, this is what happens when, this happens. This is what we're after, and have all the people in the same room so that, that's how the training and the knowledge transfer goes from people into, okay, so the data scientist actually understands. And it's also vice versa. Again, like, showing a Jupyter notebook to someone, yeah, it might make other data scientists fairly happy, possibly, but no one else would understand what we're talking about, right? And it's also, the point what John said as well, if we have Excel sheets in buildings, and we'll look at that and say, like, holy shit, these go up, at 11 a.m. And if you don't have the visual representation to show, okay, this is because the sun is shining and, the glass windows are here and it's in the east and the west side, that can take, weeks, if not months to understand, and, even not understanding it. But if you have the visual representation of digital twin and you can understand, okay, this is, what's going on, you can play with these scenarios. That's also how you, basically train also the data scientists in order to understand, what are we actually doing? So when you have that information from the different domain experts and, you're reaching that conclusion very, very fast, that's when you can, again, like start training it with different approaches, whatever it is that you want to do. And just as a final, I know John said before this, I'm becoming enthusiastic sometimes. So I'm going to try to be as enthusiastic, but also, keep it short, that you want to train it, also, closer to the edge or to the source of where the information is coming from, right? Not just in the cloud, but you actually have this approach that, because everything about building automation and building energy is a lot about local control first, from a resiliency perspective. So when you train these models, you want to possibly train them again in a digital twin setting. You can run these simulations and you figure out that, what will happen and visually understand this. Because otherwise, all the lead times it takes for explaining these kind of things, both, in getting feedback from domain experts or explaining it afterwards to the domain, back to the users or to the decision makers, it's almost impossible if you don't use digital twins. Because you're not going to understand what you're doing, and you're especially not going to understand what you're missing. So, and I think that's also a key point, right? Okay, we can only reach as far here. We need to grab data from, again, the weather, or from, we need to talk to this person, and, understanding the context. Context is everything when it comes to AI or machine learning development. And without it, we're just solving a silo problem that will lead to nowhere, if that makes sense.
And if I may, there's a question here from Ala, which kind of ties into that, because he was like, how do you classify data coming from the different BMS systems? And you've kind of touched on that, and that you're getting different data, you're getting different data sources. So, so how are the AIs clever enough that they can start interpreting some of themselves, or is it a very manual process?
I think it's both. And I think it depends on what you're after. So again, like going back to building automation or standards in whatever realm, there are always standards. So whatever you're doing with digital twins or AI or machine learning, you have to understand that, catering to standards is not just catering to one standard, but using platforms and approaches that can cater to any standard, because these are subject to change, right? So standards are really good. And taxonomies is, again, like a framework. Ontologies is more of a rich, framework in terms of bringing, how everything fits together. So using industry taxonomies and ontologies to sort of like standardize the way that we're exposing data to machine learning or approaches or AI is really, really important to get the scale and to get this done in a standardized way. So that is one thing I would say that we're using, of course. And again, you can look at digital data language or Haystack or Brick Schema or anything else that is out there to use that to, again, structure the data and tag the data accordingly so that you get something that is unified from different vendors so that you can actually, work with AI on top. So that is one way. Is that automated? Not necessarily. But again, if you have companies that prescribe to different standards, and you have the 10 different solutions that John was mentioning before that are using industry taxonomies and standards, that makes it possible so that you don't need to spend 1 month per API to figure out what they're saying, but you can actually get that done, in 1 day or 1 week at least, modify it a little bit. So standards, is really crucial in terms of getting the interoperability perspective and creating faster time to value creation. Is this automated? Not really, but having a standard to point at, is better than not having a standard to point at, to be honest.
Okay, at least you have something that people can disagree on, but the same, you can apples to apples. Now, if I may, just another follow-on question, Nicholas, there. Harry had asked, you mentioned a couple of different, let's say, AI techniques that I would heard or whatever there from your answer in terms of, but what kind of algorithms, AI, because again, AI means many things to many people. There's neural networks and machine learning and advancements, and blah, blah, blah. What kind of, what algorithms and models are you seeing most prevalent out there today?
That's like how long is a rope? I think it all depends on, how fast you want to reach somewhere, what you're going to do at what level. Are we talking like in the building, on a sensor level, on a grid level? Do we want to expose data to, feed it into something else that the grid owner wants to use? For me, I think it's, that's not the great question. What is the impact that we need to, get towards? Who are the people that needs to, be involved in the decision making? What kind of information they need to get the insights necessary to take the action? And again, like this is, I'm not a data scientist. I work with them, and they would probably say, yeah, we use regression trees, incremental models, and auto tuning, or TinyML, or Monte Carlo, some things, whatever. I mean, it's just like, it's the same when you're building a house. What tools are really good right now, right? Is it the hammer? Is it the nail gun? It depends on what part of the house that you're working on. So I think like, again, like, for me, edge native strategies is really good. Using methodologies, again, to have, open source, of course, really powerful to use that so that you don't reinvent the wheel too much, and working with standards. So I think like that's sort of, I want to bring it back a little bit, because getting into the nitty gritty, then I need to understand what someone is after and the context of why they're asking that question, if that makes sense.
No, there's no single programming model or whatever, right? As you say, it depends. But John, there's a question that's come in here, and it's quite fascinating. Being an engineer, we normally have some way of saying how accurate something is, measurement or thing. So the question here from Scott is that, how do you measure the accuracy of a digital twin?
Well, I guess the question is, what are you trying to compare? What are you comparing the digital twin to? I mean, it's as accurate as the data that comes in. So it's as accurate as the CAD model, it's as accurate as the sensor reading. I mean, one of the things we haven't really talked about is data analytics, but another step in this process, once you start gathering data from a building, is to apply data analytics to it. And that's where you start to pick up inaccuracies, typically in the building itself. You'll find the sensors hasn't been calibrated correctly, or the sensors mounted right next to the, where the hot air blows out, so it's reading consistency too high, or there isn't a sensor at all on the HVAC on the third floor. So the accuracy, really, the combination of the digital twin, the real-time data analytics, that's kind of the first phase. And you'd be amazed when you go in and start analyzing the data from a building, you're going to find 30 things that need to be fixed before you do anything else. Sensors need to be calibrated, sensors have gone dead, sensors are in the wrong location. So the accuracy is really, the digital twin and the analytics helps you pick up on inaccuracies in the source material. Once you've got that fixed, the digital twin is as accurate as the data coming into it.
Alrighty. And if I may, there's two there's two linked questions here, so I kind of throw them out to both of you. Krishnan is asking, okay, so you train the AI models, but then who judges if the human and the machine decision are in balance, or how correct are they? And Ian Humphrey Smith is asking again, how do you validate the outcomes from the AI learning? So, how do you make sure that whatever Skynet doesn't take off?
No, and I think it's a great question. And just again, from the real world, when we're implementing this with the schools, we're talking to the principal, and she's like, Nicholas, I don't care if this is a self-learning, AI-driven, Skynet making kind of something. I just want a great building, for the teachers. So this is again a school. So for the teachers, so that they have a healthy, work environment. And if we, going to complain about something, it's going to be easier for us to, to make ourselves heard and make ourselves understood. So that's, from that perspective. If we go back again to the, the HVAC side or the energy side of buildings, it's not always, and maybe all the energy specialists here might, disagree, but it's not always that the user has been taken into account. It's more about the energy savings, right? So I think I saw some question here, like what do you do about occupancy or thermal comfort and all these kind of things. And I think that's, again, if you look at a different perspective of digital twinning, you have something called physics-based modeling, where you can actually bring in a lot of information about the components and the model and make of that building, and you can actually do this physics-based modeling pretty accurately. What is the thermal comfort, and if you bring in real-time data into that equation, you can actually model this and create a feedback loop that you make this models train themselves and learn the occupancy when they were being occupied, the behavior of that building, and create basically a digital DNA. So instead of, we talked a lot about, getting data over existing systems. That is usually painful, especially in building automation side. And, it takes a lot of time. But if you would go in, which we did now with the schools, with a complete wireless mesh approach, and say, okay, we're going to have, occupancy, CO2 sensors, temperature. This again was a smart heating solutions. We put actuators on the what do you call it, the radiators, right, to control them in real time and to feed that data maybe back to the grid owner, to the heating system. We didn't necessarily take out any data from the existing systems. We just slotted them in, installed it, and it wasn't necessarily a breeze all the time, based on what John was saying. Some stuff was working, positioned maybe incorrectly, even though we gave specifications. So getting in fast, creating a baseline that is up to date in real time, couple that with a web model, is a way to stand up a digital twin in a couple of weeks. And that's when you get a real-time understanding, what goes on with this building, when are people using it, how are people behaving, where are they moving, and that in itself can then feed back into the heating, ventilation, air conditioning system as a continuous baseline that works as a complement or even a replacement for these PID loops that were created way before the building was built or changed, and we didn't have climate change, so it's like everything is off. Because a lot with buildings, as some of you might know, sometimes it's too warm, sometimes it's too cold, and you want to have that feedback loop. So in sake of trying to answer that question, how do you validate this, or how do you get this to work, it's also bringing in not only energy but from a comfort level, maintenance level, and creating a dialogue, basically the digital twin as a dialogue engine between the actual users of the building and the data that is being fed into the building. So you can do a lot of different things, but I mean it's not when when the rubber hits the road when it becomes important, but the combination of prototype twinning, simulation digital twins, and real world digital twins. So you have basically a dev environment, stage environment, and a production environment for these models. The digital twin, it's a fantastic tool to work on even before you do it in the real world, and then getting instantaneous feedback loops. I hope that makes sense, but that's how we're doing it right now within the schools that we're optimizing with self-learning systems.
Yeah, I mean, one other comment. I mean, one way it shows up is in reduced energy bills. You're going to get a typical building 10 to 30% energy reduction just by fixing all the problems and identifying the problems. You'd be amazed. Most buildings are wasting a lot of energy. I think the US Department of Energy estimates 30% of all energy goes into buildings is wasted. So fix that, and that shows up in the bills, and then you've got to do everything Nicholas says to make sure the building doesn't become freezing cold, too hot, massive CO2 levels, all the things that make the building uncomfortable to use, and balance those two things. But you're almost always going to get a significant bottom line saving, with any building when you start doing this stuff.
Yeah, and I think like in the smart building space, we have the 330-300 rule. $3 is spent on energy, 30 is built on maintenance, but 300 is spent on payroll and people. I think like right now after COVID as well, it's not that they start with energy possibly, but they might even start with providing a good indoor well-being, productivity play for people, because that's where all the money is. But if you go back to the energy side, if you just look at the capabilities of what a digital twin can do for the building, and and the context of that building is pretty important where it comes to frequency regulation. So if you look at California, everyone is charging their electric vehicle, and you have like loads going up like this. That is not amazing. So if if everyone all the buildings would be having like the capabilities of real-time control, not just monitoring, that would mean that grid owners are going to pay real estate owners, say like, okay, if we can ask you to disconnect a couple of the things in your building or factory, whatever that is, 6 times a year, 10 times a year, when the rest of the grid needs it, needs balance, we're going to pay you a lot of money to do that. So just looking at the energy side is it's again missing a lot of the value that comes with digital twinning, and the ability to start somewhere and scale basically infinitely into other buckets, benefit buckets, if that makes sense.
Now we've got about 15 minutes left, and there's a couple of questions here that I'm going to use as I'll put on my devil's advocate hat, right? And what I mean by that is, again, I'm a technology guy, and it's like, oh, cool, we can look at all the stuff we can do, and yes, you can do all of this.
Talk about the metaverse now, Kevin? Is that what I'm hearing? Is it a metaverse question?
I haven't got there yet, but you beat me to it. Hold that thought. But seriously, the technology exists. It can be done. There are benefits for the users. What are the barriers people are facing in doing this? If it was that easy, everyone would have done it already.
Financial is the biggest one typically. So, the people responsible for doing this stuff are typically the facilities management and buildings. Those guys operate off a very tight budget. They've got a limited horizon. So you've got to go to them really, hey, here's all the benefits. But the first thing you've got to lead with is this is going to save you money fairly quickly. We typically say within 12 months, everything we do will be paid for by the reduction in energy usage. And that really only works for probably slightly larger buildings at the moment. So I'd say, Nicholas, you may disagree, but 60, 80, 100,000 square foot up is kind of where we spend most of our time. Yeah. So that's the biggest barrier is there's a lot of different things that have to come together. So there's, they need help pulling all those disparate bits, the sensors, the installation of the sensors, gathering the data, getting the data on the edge, getting the data in the cloud. I mean, all those things have to happen. And then analytics and figuring out how to analyze the building and how to fix the things that are wrong with it before you even get to AI and ML. So there needs to be some, consulting and technological help. Nicholas does it in Sweden. We've got other people we work with who do it in the US and other parts of the world. But the biggest challenge usually is, hey, there's an upfront cost to this, and you've got to convince the facilities management that it's going to save them money pretty quickly. The sustainability team cares less. They're more interested in a good story they can present to the board and to the investors. But that's the one I run into most often. Nicholas, you?
No, I definitely agree. I mean, it's not technology, of course. It's people and processes. It's not part of this budgetary cycle. Come back next year, and it's also the point with stackable benefits. How people are making decisions today is in one silo. Like John was saying, maybe it's the facility management people. They have a budget for a part of that building, but the benefits of digital twinning or AI or this energy perspective, that will spill off into, again, like the technical asset management in operations, maybe the IT perspective, the well-being, productivity, the ability to attract, tenants, all this kind of stuff, but they're not measured within that budget. So it doesn't matter, people are just sitting there and saying like, yeah, but I mean, this is the budget I have. Their ROI right now, based on what you're doing, even though it's fantastic for everyone else, I don't really care. So I think like that's sort of, yeah, it's really a challenge. It comes a lot with the business model. So if the business model might change, that we need to see faster uptake or more as a service or whatever that could be, I think that could change a lot. But it's definitely, again, it's not technology, it's the existing people, the cultures, the processes, the hierarchy, and also existing systems that are in buildings. Where I always say that digital twins should be seen as a complement to existing systems, but that's not always the case with political agendas. As like we already have this, not invented here, or there's a fear of they're going to take someone's job, Skynet or whatever. So it's seldom about technology, and it's literally everything else that stands in the way.
Alrighty. And if I may, there's kind of a follow-up question to that. And as you mentioned, it depends on the business model. It depends on what they're looking for. Here in Europe, we now have the entire Repower EU package rolling out following the tragic consequences of the Russian invasion of Ukraine. So the cost of energy has skyrocketed. So suddenly maybe some of the equations where people were looking at, well, how much do I invest to save how much energy? That equation has changed dramatically in the last 3 or 4 months, right? So that thing. But one of the questions when it comes to sustainability would be, okay, so I need to, let's say either it's a new build or a brownfield site or whatever. So I need to install more sensors. I need to have a digital twin. The digital twin is going to use compute power. How do I balance the scope 1, 2, and 3?
Yeah,
everything for that.
No, I mean, I think that's a great question. I think like, the innovation proposal, we're in together is sort of catering to that, right? It's an innovation tender. The municipality wants, we want a self-learning, platform-independent, smart heating system packaged with AI that can basically, do everything and everything, right? So what we did was that, again, try to source as little as possible, work with physics-based modeling a little bit, understand, what to do, most bang for the buck, but also, subscribe to information in the energy mix, so that the digital twin, you teach it, okay, use energy or electricity, or in this case, heating systems when the producer is using, green energy, and don't do it when it's using, fossil fuels. So I think like you can basically, the digital twin is not, again, like the part of digital twins for a building is everything with the context can be tied to that digital twin. So I think that's how we do it in order to sort of understand exactly what is going on at any given point in time and make these split decisions, again, like what John was saying. It's very, very hard, if not impossible for a person to do in the long run. That updates, it learns itself, and it's just, uses energy or optimizes itself based on having as low carbon footprint as possible, not just scope 1, scope 2, but also scope 3, and looking at the holistic perspective. And I think that's, something that, digital twins really, really excel at. That's what we're seeing. And again, visualizing that in a way that someone else can understand, not just, cryptic language. But please, John, yeah.
Yeah, the quick comment on actually the digital twin itself. These are very, very low compute power compared to CAD, where you've got to have a pretty sizable sort of workstation to do anything on. We run happily on an iPad or an iPhone. It's not a power hungry technology.
Okay. And if I may, another question here from Danielle, again, devil's advocate thing. How do you deal with data ownership and digital twin? Who owns the data? The perennial question.
That's really a business decision. The way our decision on the philosophy we take is it's your data, it's the customer's data. The reason for that is, there's medical information potentially, there's GDPR, there's all sorts of legal ins and outs. We don't want to try to sell or mine that data to and sell it on to make money. That's not our business model. So from our point of view, the data, we host the data for you in Amazon Cloud, or typically Amazon Cloud or Azure. But the ownership of that data belongs to you. And a lot of the problems that go with ownership of that data is your problem, not ours. That's kind of our approach.
I think that is definitely, what I see as well. But I'll also think like in the digital twin consortium, we've talked a lot about virtual ownership of data. And again, that data, especially information leading to, insight, action, and impact, that is where, the information that is being, created on top of all these products is even more valuable than the products where they're coming from. So I think, the short term, definitely, right? Be prudent to know who's owning the data, where it's being stored, but there's also like a monstrosity in terms of an opportunity of creating value of the data that, is being generated, but not necessarily taken care of at all times, where the digital twin, definitely can help in illustrating, where do we have opportunities, what do they look like, and creating this, again, like virtual ownership structures where it becomes very, very interesting to create value across the entire life cycle.
Yeah, that's definitely a great point, Nicholas. And I see, as we get into trading energy, energy is being generated by buildings that can be resold back to the grid, especially in Europe where you've got multiple grid operators, and you can choose, you can spot buy and spot sell. All sorts of business models can emerge around that, but that's our business is data visualization. So we don't get involved.
No, and I think like that's, again, like, everyone should play their role, but the digital twin, again, like it can open up these opportunities and, cater to this so that, bring it closer, at least, again, to the impact that is necessary, because there's a lot of value in the data that both resides in buildings, but also, again, from an energy perspective, to keep the grid more stable and to work with, again, load balancing and frequency regulation in real time, because a lot of times for basically any and all energy markets in the world, it's the real-time granularity and the insight and understanding what's happening on the micro level that is needed, right? And I think, like, again, like it's with local grids or smart grids, communities is very, very interesting. And I think, I can talk about this far too long. Kevin, over to you.
Right. So we've got about 6-7 minutes left before we need to wrap up here. So I do want to come back to you to kind of your final takeaways for folks listening in terms of where do you start? What's the key takeaway from this today? But I do want to go to the M word, metaverse. Now, for folks that know me, I'm a big fan of VR and AR and a digital twin. And if you have a 3D digital twin running on Unity and whatever, to me, that's a virtual world. And there's no reason I can't walk around in there with a headset or whatever.
You can.
I suppose in metaverse has been a hype topic, and it means many things to different people. But I suppose I'd ask each one of you, where do you see that concept of more immersive environments? Because John, you mentioned that we need to be able to understand what the data is telling us and visually represent it. So what's your take on the metaverse? I know you've written on it recently.
Yeah, it's an interesting one. I mean, I was trying to explain what I did at a Christmas party, I don't know, 8 months ago. And eventually I just said it's industrial metaverse. And they went, oh, great, that makes sense. So it's a shorthand for a whole basket of technologies. The visualization of data, the interactivity. We offer collaboration mode, so multiple people can use the digital twin simultaneously. They can draw on the screen, they can do picture-in-picture video, they can do AR casting. So we do, I guess, about 90% of what people mean when they say the metaverse. And for me, it's just an intersection of all these technologies: gaming technology from one side, collaboration technologies from another side, the 3D nature of design these days coming in, enhancing the data through just computer game techniques, graphical techniques, but also augmented reality, especially as I think the hardware really evolves. So I think it's a useful shorthand. I mean, the only reason I'm a little hesitant is I think Silicon Valley is already pretty sick of the metaverse. People I talk to around here generally sort of roll their eyes when you use the term, but it's a convenient shorthand for a whole intersection of a basket of technologies that are definitely all coming to fruition.
Oh, thanks, John. Nicholas, your thoughts?
Yeah, I mean, I love this question, and I think, like, I've been having these digital twin and metaverse webinars now, almost every week the last 6 to 8 months, even before Zuckerbro counted it on Meta and hijacked it for everyone so that everyone couldn't use it anymore, right? But I think for me, it's again, buzzword bingo. It's just it's buzzwords if you don't understand what tools, what capabilities they have and in what order to use them. So for me, I think like the biggest open secret, which sort of John was saying, is that metaverse by its own offers collaboration, in an environment where people, have a shared reality, which is fun in games for the most part. But if you tie it to reality, that's where it becomes really, really interesting, right? And if you also tie it with real-time data from that specific part of the real world that I have behind me over here, that's where it becomes even more interesting, because that offers, collaboration opportunities within the real world that, we don't necessarily have today, where I can, invite anyone to the factories that, I'm in, and I can show them exactly, through Arcelius, product, this is what we're doing. These are the problems here, here, and here. And you can, understand these problems, figure this stuff out. And again, it's the combination of augmented reality, virtual reality, and, the community around collaboration that, for me, I'm trying to leverage this on a global scale every day, because it's just another tool in the toolbox that can do amazing things. So don't necessarily stare at, the buzzword bingo. Understand what capabilities they offer and how they can bring value to you and or your customers, and getting, faster time to value creation. So I love it personally. But again, I mean, the same as you, Kevin. I think, it's just another tool in the toolbox for me.
No, I agreed. Yeah, my personal thing for anyone who listened is say, oh, metaverse, oh, never happened. And I'm kind of going, we're building it already, right? With digital twins, exactly. AR, remote commissioning, VR training, you name it, bits of it are happening. Anyway, right, the clock is against us. So John, Nicholas, come here, thank you so much. Before we close out, I just want to, I suppose, for folks that have been listening and will watch the replay, Nicholas, if someone is looking at, I need to start thinking about digital twins and AI control for building energy management, what's your one takeaway for them?
One thing that we haven't even touched upon, and shame on us, is of course security. That has to be talked about. That is really, really important when it comes to these things. But you just start with where. There are experts everywhere in the world. The only problem that you probably have is, how do you explain your reality to someone else? But if you use, again, these kind of tools to actually show the reality that you're in, then you can do what I call invite to innovate on a global scale. So just, pinpoint where are you, where are your problems, use, visualization tool just to visualize that, and then bring people in, they can give their advice into your reality. Don't do the traditional way, looking at, different separate platforms and try and evaluate something that you don't necessarily have an idea about, but you do, and you should have an idea about the reality that you're in. So use that and, work with your reality first, and, where are you, et cetera, and then, start with that perspective. That's my recommendation. And don't start with AI or IoT or digital twins. I mean, start with, what are the problems, or what do I want to do, and, what stresses me out, bring it back a little bit, and then we can talk about, maybe AI, digital twins can help. Yeah.
And John, from your side?
Yeah, I think what Nicholas says is absolutely 100% accurate. I mean, theoretically, I could go to my local hardware store, buy everything, and build my own house, but I'm not going to. I would get an architect, I'd get a general contractor. It's the same thing. There are people like, we do this all day, every day. We understand the sensor side, we understand the data gathering side, we understand the analytics side, we understand how buildings work, or we have people we know who understand how buildings work. So the expertise is out there. And I think if you start, okay, I want to be more green, and I want to save energy, and I want the building to work better, and I want it to be a nicer environment, and then, there's people like ourselves who can guide you on how to do that.
Yeah.
All righty. John, Nicholas, thank you so much. We're right up against the wire, folks. Thank you, everybody, for joining. I apologize we didn't get to all the questions. I know the team will be following up. But with that, thank you so much. And I wish you all a good day. Take care.
Thanks.
Thank you so much.